Okay, it's 1:33, so let's get started. So this webinar is part of the Easy webinar series that we've been holding. This is the fourth session now, and we started in May, and then it'll finish next week, the fifth session. If you want to ask questions or anything during the session, the best place to do that is in the EESSI Slack. That's primarily because there's a lot more people looking at the Slack, so a lot more people will get notified of your question, and especially if it's a complex one, that's a really good place to ask that question. And there's a special channel for that if it's related to this specific session. And so that's the webinar series 2025, quarter two, Q2. So that's the channel there. And if you haven't already joined the EESSI Slack, you can find it on the EESSI website, so eessi.io. And then there's it in the slide deck. The previous slide decks are already published, but there's a direct link there as well to the channel. Okay, so let's get started. So the webinar series, just for those of you who haven't been attending all the sessions so far, the idea was that we wanted to cover different aspects of EESSI. We've had 4 sessions. This is the 4th session. So the idea was like Easy Mondays, right? So 5 Mondays in a row, and that we started in the beginning of May. And there's a lot of documentation about those sessions and links to all the material as well for the sessions that have already taken place on the EESSI website. So that was an introduction to EESSI. That was the first session. And then for people who are looking at deploying EESSI, there was an introduction to CERN VMFS, like especially in an HPC context. And that was the second session. Last week, then we had an introduction to EasyBuild, because that's one of the technologies that's really underpinning what we're doing inside EESSI. Today, I'm going to cover EESSI for continuous integration and continuous delivery, and I'll explain what that means today. And then the last session then is if you're taking EESSI quite seriously, then you might be considering to use EESSI as a base for your system software stack. And there's a session on that next week that will talk specifically about that. So there's a QR code here on the page if you want to get a link to those sessions. So I'm specifically here to talk about CI/CD, so continuous integration. In my case, continuous delivery, not continuous deployment. I'll get to the difference between the two of them later on in the session. I am Alan Okash, so I work at the University of Barcelona. I also have a kind of affiliation with the CCAM, which is the international European organization related to molecular modeling. Atomistic and molecular modeling, and based out of the headquarters are in Switzerland, but it has nodes all over Europe. I'm also the technical manager of Multi-X Scale, so that's the project that's kind of bankrolling EESSI at the moment, so where we get most of our funds right now to do the development work that we do. That comes from Multi-X Scale. That's a Euro HPC Center of Excellence, and I'm the technical manager there. So about today's session, before we get going, there's some things that would be useful if you knew something about them already. So basically what I'm trying to tell you about is things that I won't cover today, because they've been covered in previous sessions, or they're kind of like background knowledge that would be good if you had for this type of a session. So what I won't cover is what's been covered in the previous episodes. So I'm not going to explain to you what EESSI is and how it works. And I'm also not going to explain to you the EasyBuild as well. So how EasyBuild works, will give you an introduction to EasyBuild. I'll explain the things that I use. Hopefully I'll explain them pretty reasonably, but I'm not going to go into the details of the design inside EasyBuild or the design inside EESSI. For this session, because it's on continuous integration, so hopefully most of you have built some software package in the past, right? So you have an idea what's involved in the build process. So maybe you've compiled some code, or you've installed a Python module, or you've done something along those lines in the past. And it would be nice if you'd heard of some of the tools that are out there to help you to do that. So if you've heard of CMake or Auto Tools, which are like build and installation frameworks that are quite commonly used, that would be good as well. It's not essential. They will come up today in particular. We'll be looking at a project that uses CMake. You don't necessarily need to know the inner workings of CMake, but when it arrives, if you've seen it before, you get an idea of what's involved. The other thing is that you should be familiar with Git, right? So we're going to use Git quite a bit during today. So I'm going to assume that you have some experience with the Git command. And then nice to have here was because we're talking about CI and CD, and usually that involves some kind of remote manager for your Git repository. So it would be good if you were familiar with something along those lines. So say like GitHub or GitLab, they're the big ones these days. In terms of the session itself, I'll give a kind of a flying introduction to what maybe I think CI is, so continuous integration is. I'll navigate EESSI to show you how to build a project. So we'll look at an example project and then we'll build that project using EESSI. And once we get that the build process in place, we'll look at how do we do that build process with the EESSI GitHub action. And maybe I'll also walk through what a GitHub action is when we do that. And then the next piece will be navigating EESSI build to build with EESSI Extend. So there's a module inside EESSI they're called EESSI Extend that allows you to extend EESSI with your own software. But that requires you to use EESSI build. So we'll look at how to use EESSI build to build our project as well. Once we have that in place, then we'll look at building using EESSI Extend with the EESSI GitHub action again. And then finally, we'll also do the same thing, but with the EESSI GitLab component. So doing CI, instead of just doing it on GitHub, we'll also look at doing it on GitLab as well. And the nice thing about the GitLab component is that works on the public gitlab.com, but also works in private deployments of GitLab as well. I'll also cover a bit, not too much, about continuous delivery and what EESSI can offer in that space as well, because our services right now are mostly focused on continuous integration. We do have services for continuous deployment as well, and they're expanding, but they're not at the same level at the moment. And then I'll leave time for questions and answers at the end. So let's get started. So what is continuous integration? So in general, it's a best practice in software development, right? So it's this idea of frequently merging code into a place where other people can see it. So if you're collaborating, especially if you're collaborating with other people, where people can see the code development that's going on. So it's in general that practice, but these days that would really be considered the best practice for software development. And the other thing it is it attached to that, then you have like automated building and hopefully testing of your project as well, so that you run that on each code change. So when you make these changes and that something happens that gets triggered, that automatically builds and runs tests for your software to make sure that it can build, that it's successfully built, and then also that it's correct, right? So test it to make sure that it actually works. And it helps to detect bugs early, right? So because this is run every time you push code up to your remote repository, it hopefully should help you detect bugs in your code very early on, and also help you improve code quality. So if you do this in what these days is a pretty standard workflow of creating pull requests in GitHub parlance or merge requests for GitLab, this idea of making a proposal in terms of code change, then somebody else can come along and review that code change. And because you have these processes running as well, it makes that job of reviewing the changes that somebody is making that much easier. So this is also another best practice, right? So doing code review and code quality checks. It provides immediate feedback to the developers. So there's a way of getting information back out of the system so that you know these things. So right, it builds your code, it runs your tests, and you want the information related to that, especially if it doesn't work, right? So especially if something is failing, you want to know that it succeeds, but if it fails, you want to know the details of where it actually broke. So you want access to that information. And the other thing is it allows you to ensure that your application is always in some kind of a deployable state, right? So you know that if it can build in CI, it should be able to build in real life as well, right? So we should be able to build the code at any point in time from the repository. So what are the key components then of CI? So one is that we have some remote repository, right? So we have a version control system where we either a version control system first. So in this case, we're talking about Git, and that is the most common one out there today. And there are other options in terms of version control, but they're not, in my experience at the moment, they're not so heavily used. You need an automated build system. So I mentioned CMake and Auto Tools already. There are others out there. Those ones are like quite common, I would say, but automated build might be scripts as well. But there's a lot of additional features that are offered from these larger tools, so it's interesting to look at those. But basically, you need some way of automatically building your code, and you also want to make sure that it's correct, right? So ideally, you have an automated test suite as well, so that you can test your software to some extent. And there are different levels of testing, and you can do short testing, which is probably what you would do, say, on a commit to a repository, or you can do more extensive testing, things like regression testing as well. And both of these can be automated. And then you need a way of getting the information back, particularly if something is not working. So what are the benefits of continuous integration? Well, one of those benefits is that you get this early detection of problems. So if an issue arises, and especially if your build processes is one thing, but your test suite, if your test suite is good, you'll get early detection of any issues that you might have. It means as well that you have faster and safer release cycles, right? So because you know that things already work and you're fixing problems as you go because you're notified that they exist, right? You're unlikely to leave them in place. So you're fixing problems as you go. So it means that when you do come to like near the end of a release cycle, then you have less work to do, right? Because most of your problems have already been solved. It encourages small and incremental changes, right? So especially when you have this idea of code review, and you want these changes that people make to be manageable for somebody else to review, right? So it helps you to, as part of a workflow, to like it's like a carrot in that workflow, right? Because you know that somebody else will be looking at it. You want to make these integrations small enough so that somebody else can manage that, and it encourages you to do that. And as a result, then you get improved code quality. All right. So in general, because you have things like coder, or you're able to have things like code review and code quality, then you can have code quality checks as well. And it means better collaboration among teams members as well, right? So this idea of having pull requests or merge requests and other people looking at somebody else's code, it encourages collaboration. You also see how people work, right? How do other people develop code? So it's good as well in kind of a mentoring way to see that what the process is for people to add and develop code for a particular application. And then it's easier refactoring, particularly if you have a good test suite, right? So if you feel like you could trust your test suite, then it's easier to do things like refactoring because you can trust your test suite to catch problems, right? And so that's high value, right? It means that you're not afraid to make changes, right? Because you can trust your test suite to catch them for you, and then makes code maintenance easier as well. So specifically in an HPC context, what are the challenges related to continuous integration? Well, one of the things is that we typically want software that's really, really new, right? So we're not necessarily interested in the compiler that comes with our operating system. We want HPC suitable tool chains, and we want HPC suitable dependencies. And that typically means that we want things that are quite recent, right? Very, very new compilers. We want very new other new software that we require typically needs to be pretty new. We also probably want to deal with MPI. So if we're talking in the HPC space, the way things are and the way things have been for a while is that if you want to do inter-node communication, you're typically doing that through MPI. So you need a way to handle MPI in your HPC, in your CI context as well. You're also probably interested in specific architectures, right? So in both CPU and in terms of accelerators as well, you're probably interested in specific things because that might be where you are executing your code, right? So it's great that you can get like free CI services in GitHub, but if they only support x86 and you want to run on the Fujitsu machine in Ducalion in Portugal, then you're a bit out of luck, right? Because you can't actually test your software for the resource that you want to work on. And the other thing is you want to have accelerator support. So you want access to things, or at least many people would want access to things like accelerators. So you want access to a GPU, maybe even a specific GPU. So that might be like NVIDIA or AMD, or maybe you want access to other types of hardware or accelerators. So like in the future, that might be something like a RISC-V accelerator or something like that. These things are not typically available within CI services because they're niche hardware in general, or they're expensive hardware in the case of something like a GPU. And finally, then, the other thing that matters is not just that your code builds, not just that it is correct. So you run tests on your code to make sure that it gives correct answers. But in the HPC context, you also care about the performance of that code and how well it scales, right, typically. And so these things are an important issue. And that's why it's something that you want to check at some point in your release cycle. You're going to check the performance and the scalability of your application as well, because you don't want to see regression there. You don't want to see your code all of a sudden perform worse than it did before for some feature because of some feature that you've introduced. So specifically talking about EESSI in this CI context, we have two tools that are out there that you can use. So we have one for GitHub, So that's in the Action marketplace, right? So there's the EESSI GitHub Action, and then in GitLab as well. They have a catalog as of like about a year now. They have a catalog there as well, which is something similar, and so we have a component in the GitLab catalog as well that you can use. So what can EESSI provide? Well, it can provide the EESSI environment. What does that mean? It can provide different compilers for you to test your software with, usually very recent versions of those compilers. And it can provide any required dependencies that you might have. So particularly in the HPC space, you may have a lot of dependencies related to your software, right? That are either direct or indirect. And you don't want to manage all those dependencies because you care most about developing your own particular application, right? So EESSI might be a tool that can help you to manage all those dependencies. There's also additional tools in there, so things like Reframe or other performance analysis tools that maybe are part of your workflow and maybe might be useful for you to also in the testing arena as well. There may be additional things or tools that might be of use to you that we can provide. Other than CERN VMFS, to get access to EESSI, you don't actually need to do any installations, right? You just need to make sure that CERN VMFS is available, and then all of the software that EESSI provides is available as a result, and that's pulled in on demand by CERN VMFS, and that's exactly what our actions are doing for you, right? So our GitHub action, our GitLab components, they're really just setting up CERN VMFS so that you can access the software that's inside EESSI. And because it's all based on that single environment, right? So this EESSI environment, and it really makes it quite straightforward then to also run CI tests in other contexts, right? So you can run the same set of tests on your local laptop as you can run in cloud environments, as you can run in your CI platforms as well, right? Because you're running in exactly the same environment, maybe on different hardware, but it's the same software environment. So most of the session today is going to be a big, long demonstration, right? So I'm going to talk about a particular application that I created using ChatGPT just for this webinar, and we'll talk about. We won't really look into the details of what that application does. Indeed, I haven't even done it myself. I just made sure that the tests and everything run in that it builds and that the tests run in it. And so we're not going to look at the details of the application. We just know that it has dependencies. It needs HDF5, an MPI capable version of HDF5, and it needs MPI as a result of that. It's built with CMake, and then it's running some tests via CTest as well. For the demo, there's a cheat sheet as well. You don't need to look at that right now, but if you want to go back and look at things later on, you can. One of the first things I want to do is show you that for my... Just hide this. One of the first things I want to do is show you that anything I do in the shell, I have something called shell share, so you can see actually the text that I run in my shell. So if you need to look back at something, or I run a command, for example, if I'm looking for the help information from EasyBuild, that's usually a lot of text, and maybe the commands that I run will get lost as a result. But this has an entire log of my shell session as well. So the guys have that the URL here, and they'll put it in the chat and maybe in Slack as well, so you can see that as well. We won't use it just yet, but just so you have it available. So here is the repository. So this is the CI/CD demo that we created. You can see it's just a couple of files, right? So we have the CMake list file, which is a file related to CMake that tells it like what to build, how to build it, and also how to build tests in our case as well. There's a license file, there's a README that we'll look in a second, and then there's just two files, two main C++ files. So there's one that actually does writing out a file using HDF5, and then there's another verification script that's used to create an executable that's used in the verification step for CTest. So all it is MPI HDF5, and it's basically just a hello world. So it's very simple. We're not going, like I said, we're not going to actually look at the code itself right now. It uses MPI to run on multiple processes, and it just writes information from each rank to a specific file. It has a couple of requirements that we are aware of, right? So it needs CMake, a certain version of CMake or above, and it needs MPI. Could be any MPI, OpenMPI or MPitch. Both are good. And in our case, we'll be using OpenMPI today. It needs HDF5 with some kind of C++ support, to an extent at least. And then it gives us information about how do we build this application using CMake. So it gives us the information that you might typically see about how to actually make something available, how to make it work. And it explains how to run it. It explains how to verify it. So how do I verify it at the end? And then there's some optional arguments that you can give to it as well. So on the testing side, it also explains how to run the test step for the software with some options as well, right, to make it more obvious about what exactly is going on. And then if you actually want to install it, you can do that too. So that's just a make install at the end, right? That gives you the install step for the software as well. So that's what we have. I've already made a fork of this repository, right? So this is in the EESSI organization right now. I've already made a fork of it for myself. So all it just has this single branch. In the EESSI repository, if you go back and look at this later on, there are different branches there because they'll have solutions to some of the things that I'll be going through later on today. But we're actually going to do everything from scratch ourselves. So we have this CI/CD demo, and I've already cloned that locally, right? So I can do my git status here, or git status. So I've already forked this repository and I've cloned it locally, and we can do a git remote as well. Git remote -v. We can see I've actually set it up to push to a location on GitLab as well, but we won't get to that at the end. But we can see the origin here is my repository on GitHub. Okay, so again, we have the files that we just walked through here, and we had the README, which told me what I needed to do. And I've been through this process before, so I don't need to read that again. I have a rough idea of what I need to do. So first, I need to make this directory a build directory. That's the first thing it asked me to do, right? I can go inside that directory, and then I could run the CMake script, but I don't have CMake. So if I do which CMake, we'll see that I don't. Whoops, I don't have that available. I don't know why you didn't complain about that, but let's do a module list. Yeah, module command family. I don't even have modules available at the moment, right? That's because I haven't initialized the EC environment yet. So that's the first thing I'm going to do. So I know all of this off by heart. So we got software.easy.io, and then we go to the versions and 2023-06. So all the software right now is in that version of EC. And then we want the initialization. We can do bash. Actually, we'll do lmod because the lmod subdirectory has different shells, but I still want the bash shell. So I'll do that. And now it says, if I do a module avail, I'll see that things have happened, right? So now I have lmod available and I have all this software available to me, right? So I know that I need two things, right? I need CMake first, but I also need HDF5, right? So let's load the two of those. Now let's do module spider to see if these are available first. We can see they are available, right? There's 3 different versions of CMake available. I don't actually care about the version. I know that this is going to work because I've tested it already, but I won't pick a particular version. I'll just load CMake. We'll do the same thing, module spider for HDF5. Let's see if that's available. Okay, we see we have 3 versions of that as well. So in both cases, I'm just going to take the most recent one. And to do that, I just don't give any version at all, and would automatically choose the most recent one. And now if I do a module list, we can see I have a lot of stuff actually available, right? So I have HDF5 is loaded. I need that. And way over here somewhere, I have CMake as well. That's loaded. But then all of the dependencies that those things require are also available to me right now. So now I'm in my build directory and I want to run my CMake command. Since I loaded the CMake module, that's now available. So I can do CMake ... And it goes away and it's doing things, right? So it's telling me, oh, I've recognized that you have this compiler. It's GNU, it's GCC 13.2, and found the compiler. It's found HDF5 as well, right? So it recognized that was available, and it found the CXX component for HDF5 that it needed. And so it configured, created the build files, and now I can actually make that. So I can do the build step. So make. So we can see it compiled one, and then the other of my C++ files. It created an executable, hello MPI HDF5, and verify HDF5. And now I had the ctest command as well. That one I don't remember by heart, so I'll take it from here, from the website, and then put it in locally. So ctest, I want to see the failure, so I want output on failure, and then I want it to be verbose as well. So tell me everything that's happening. And this is okay in this case because I have one test, right? So it's okay to see all the information. If you had an entire test suite, you probably wouldn't be doing things verbosely, at least not on the screen right now. So we can see that, our test failed, right? We had 2 test failures out of 2. So everything failed. And because I printed everything to the screen, I can see why. Okay, so things didn't work. Why didn't they work? So let's go back up a little bit, right? So it's doing something to run an MPI code. It's trying to run hello MPI HDF5. And there's a problem. Okay, here's my problem. It says errors while loading shared library, right? So even though I give it the HDF5 installation at runtime and it compiled, it didn't have a problem finding that library when it was trying to compile, but at runtime, it's not finding that library, right? So why is that? Let's have a look, right? So let's have a look what we have in the current directory. So we've got this hello MPI HDF5, and we can look at the libraries that it's trying to load at runtime with using the LDD command. So let's look at that. So LDD hello MPI HDF5. And we can see, oh, there's a few issues here. It's complaining about libstd C++ and something to do with glibc. Oh, that looks weird. It can't find MPI. It can't find HDF5. It's found other things. So it found libz. It's found libm. And down here, it's telling me what dynamic loader it's using as well. So let's have a look for a second at what a dynamic loader is, or dynamic linker, right? There's lots of different names for this that people sometimes use, right? So I queried it today about what the best name to use in a kind of a training scenario is, and they said dynamic linker is probably the best way to describe this. So what is a dynamic linker? So I have a little picture for this, right? So when you create an executable at runtime, that executable inside is linked to what's called a runtime linker. And that runtime linker, its job is to figure out what libraries am I supposed to load to make this executable work, right? And now, normally, or on an operating system, that dynamic linker is usually the one that comes from your operating system, right? So it's going to be in a location like a /user. Well, we'll see in a minute where that typical location is. But in our case, because we're using EESSI, we're actually going to use the dynamic linker that EESSI provides, right? And then, the reason for that is because we, the EESSI, the team who are building EESSI, we control that linker. We can tell that linker where to look, right? But that linker is the one that decides where to find libraries, okay? Now, so in this case, the linker is going where to look for libraries. You need to tell it where to look, right? So when we compile things, there was information given to the compiler about the location of the libraries, right? And the compiler found those libraries, didn't complain because it found the libraries, and then it created executable. But at runtime, we need similar information, right? Now, a standard way, or one of the common ways to do this in a HPC space, is to use LD library path, right? Which tells the linker, here's some locations that you can look in to find these kinds of libraries. There are other ways of doing it, and one of them is one of the ones that we use in EESSI, which is called R pathing. So we give specific location. We say you should look in these specific locations for libraries, and we inject that into an executable. Those paths, we put them in the executable when we create them. When you are using EESSI, you don't have this information, or you don't have the information to inject into the library, even though it's there, that's not in place. That's actually something we're fixing today. It'll actually be fixed by tomorrow. But to make it work, you need to look at it right now, today. Tomorrow, it'll be different, but right now, you need to look at the EESSI documentation. Right. So under advanced usage, there's a section about building software with EESSI. And it gives you some hints about the problems that you can have, right? And so down, let me see, over here on the right, you can see the different sessions. You can see That's building on top of EC with Easy Build. We're not doing that right now. We're manually building software on top of Easy Build. So we'll go to that subsection. There's a warning here about this, that it's subject to change. In fact, that change is happening right now. And so it'll be changed by tomorrow even. But right now, it gives you this information. It tells you that this is an option you give to the compiler, which gives information that it can pass on to the dynamic linker, right? To tell it where to find things. So right now, if we look at, see, it's using this library path. We can look at what the status of that library path is in our application right now. So because that's actually defined in our environment. So I can echo it now, but it's going to be really long because we have quite a few. So you can see, oh, there's all this information inside library path, which is telling it different locations where it might want to look for libraries. And that's what's being used by our compiler, right? So our compiler is using this library path to figure out where things are. Right. And so here in the documentation, it said, if you use this is an environment variable that's used by the compiler, and then it passes information onto the dynamic linker about where to use things. So it's referencing the library path that's defined right now, and also referencing what's called GCC core. Now, I don't want to get into too much details about what this means, but basically that's just a GCC installation. And because this is something to do with libstdc++, right? So we need this location as well. So again, tomorrow this won't be necessary anymore, but today it is, and we need to set that environment variable. So we can do that, right? So we can take it from there. We can export that LD library path. Let's clean our environment, so make clean. And let's just make things again. Again, we build things. We can run LDD on our executable as well, again. And this time we see things have changed, right? It's not complaining about anything anymore. In fact, it's finding lots and lots of libraries, right? That it needs to open, right? So basically setting that environment variable puts information inside the executable that allows the dynamic loader to load the information, all the different files that it needs. And so now if we run our test step again, so let's go back up and run our test step again. Our tests have passed, right? So we had a problem before that our executable couldn't run because it couldn't find libraries. But now we've managed to successfully build, right, our software with EC, right? So now we've got our package is running with EC. That's great. That's what we wanted. So let's get out of here. So we managed to do that. And then we can rm minus r our build directory. We don't need to do the installation or anything like that. And we need to force that because of some protected files in there. So that's it. We now at least we know how to build with EC, right? So now we want to actually run this in a CI environment. So how do we do that? Well, in the case of GitHub, the location of the files that explain to GitHub how to run your CI, they're in a particular location, right? So we're going to make dir -p dot GitHub, GitHub slash workflows. That's the location. And then in there, we're going to make a new file. So we'll just touch it for now. So .github workflows, and let's call it build. So the syntax for GitHub Actions and also for GitLab is YAML syntax, right? So we'll just make a YAML file. YAML format syntax. If you're not familiar, it doesn't really matter. You don't need to know too much about it now. It's just a particular file format. So we make that. So we've made that available. I can open that file now in my editor here. But I don't want to do that yet because I don't actually know what to put inside, right? So let's go and see. Let me close that. Let's go and see what I should put inside. So the best place to look for this is, let me close some of these as well, is in the documentation, of course, right? So read the documentation. So here in the marketplace, so the link is in the slides. It explains what the EC GitHub action does, and it gives some information about it. And here it gives a minimal example of what it looks like, right? So this is a particular case of, right? So a particular job, it's going to run on Ubuntu. You can kind of tell from the name, right? Because it runs on Ubuntu latest. That means the latest version of Ubuntu that's available in GitHub Actions. Right now, I think that's 24.04. It uses a couple of things. So if you haven't seen these things before, but this just means that it checks out the repository, right? So it's checking out the repository. it's going to use the EC GitHub action, right? A certain version of it, right? So version 3. And then you can actually test that then just by running commands. It has to run in the bash shell. So this is important down here. That's one of the requirements that we have because of how we implement things. But that's all we have. So you could use this text. But if you go a little bit further down, it says, oh, you can also, these days, right? For the last few months now, you're able to actually run in GitHub Actions, you're able to actually run on both x86 and on ARM, right? So you can get free access to ARM instances in GitHub at the moment. And those ARM instances are pretty good. They actually have vector instructions and everything as well. So their architecture is equivalent to NVIDIA Grace. So that's an interesting space to also test out. So I want access to these architectures. I'm interested in that. So I'm going to take this part. I'm going to take this job. And this time it's 2 different matrices. I'm going to be specific this time. I want to say 2404. And then I want this ARM instance as well. So the way to reference the ARM instance is by giving this. And so this matrix means that I'm going to run on 2 different things. I'm going to run on the x86 and also on the ARM instance as well. But the rest of it remains roughly the same. So I can do that. So let's put that in my editor. So I just copied and pasted it there. It doesn't like it for the moment. I actually know why that's true, but we'll do that anyway. All right, so we'll save that for now. So I'm using VS Code here as my editor, right? But so we can do a git status, and then I can do. Let me just, for anyone who's actually using the shell share, I'll just cat this file so you can see what's inside, right? GitHub. Workflows and build.yaml. Okay, so that's just so you have it in the shelter. That's what's in there right now. So I can do git add dot GitHub. So I've added that file. I can commit it. -m add initial CI. Oops, CI. And now I can push that to my repository. So my upstream is called origin, right? So git push origin, and the name of this branch is main. I'm going to push it directly to main, right? So I'm not following git best practices now. In an ideal world, I would be creating a pull request to do this, but I'm not doing that right now. Okay, so that's been pushed upstream. Let's see what happened. So let's go over to our repository. We can close that one, doesn't need it anymore. So this is our repository. We can see if I reload this, we should see some changes here. It's a little bit slow. Add initial CI. Nothing else seems to have happened. I can see I have a button for actions over here. So let's see what happened over here. Oh, there's a problem here. So something did happen. I created this workflow run, but it didn't work for some reason, right? So I can click here and see what the problem is. And it didn't report anything. It only reported here. And it says, oh, no event triggers to find it on. Now, if you didn't know what this means, I already know what this means, right? But if you didn't know what this means, I would suggest you look in ChatGPT, right? So use Google or use ChatGPT, and it will help you out with these kind of things, because these kinds of workflows are very common, right? So the LLMs are quite good at this kind of stuff. And so if you need help with this stuff, that's where you should look. But basically, my problem is that I didn't read the documentation, right? Because this was only showing me a single part of the file. It wasn't giving me a fully fledged example. If I had read the rest of the documentation, I would see down here, there's a minimal example, right? And I should have really used this. But it's pretty similar to what I had before. So you still have the jobs part. But what I was missing is minimal usage, right? So I didn't give it a name. The name doesn't really matter, but I need to tell it when it should operate, right? So when should it actually do something? And in this case, I'm going to tell it that I want to do it on certain types of events, right? I want to do it when I push to a branch, any branch in this case, but it could be restrictive. I could say on a particular branch, or I want to do it when somebody creates a pull request, right? So I just need to take these 2 lines, go back to my editor, right? And I'll put those in, add those 2. And now all these little errors that appeared before in my editor, they're all gone away because I was missing the on, right? I was missing this, right? So let's do let's rename this, and we'll call it build with EESSI. And then let's see, is there any other names down here? Yeah, this is not test EESSI anymore. This is like we can give it the same name here. This really not. Okay, but then we need to change things inside here, right? So well, we can run this now. So let's do that actually. So we can save that. Let me cat it again so that you can see it's inside. Do git add. We'll add it again. Git commit and then -m. Let's fix CI and git push origin, and the branch is called main. Now let's go back and have a look again. So that's where's my repository? So here's my repository. Let's go back and have a look at our repository. And we can see something is different here. We now have this little button over here, which is pending. Right? So let's click on that. You can see it's actually doing two things. It's building on x86, so on Ubuntu 2024.04, and it's also building on Ubuntu ARM as well, right? We can have a look at this. If it's quick, it should be quick as well, but if it's quick, it takes about a minute for the EESSI GitHub action to run the first time, and then it has some caching, and so it'll run faster the next time. So we're not going to look at the details here, because what I actually told it to do, if we look in our file, I didn't tell it to do anything yet. So what I actually told it, the commands I told it to run, they appear down here, and all I did was tell it to do module avail. But that's not what I actually need to build my software, right? So I want the commands that I ran to be able to build. So we can look at our history. So history, let's look through the last, say, 30 commands or so, 40 maybe. Let's look through the last command. So what did I need to do to be able to run my software? There was two things I needed to do, right? So there's a couple of things I needed to do. I needed to load CMake and HDF5. And what else did I need to do? I needed to make build directory. I needed to go into that build directory, cd build. I needed to run, I needed this environment variable. So let's make sure to set that too. So I copy that and paste it over. Oh, that's a bit long. That's okay. I needed that environment variable, and then I could run cmake ... and then I could run my test as well. So I can run this one here, that. And that's basically everything that I needed to build my project, right? So let's save that. And I'm very aware that this is taking a lot longer than I expected it to take. Let's see how far we get. Okay, so now that are basically all the steps that I did that are relevant to the project. That's all of them there. So let's save that. And then let's copy it. So let me just cat that again, just for anyone who looks at the thing. So, and then we do git add that location, git commit, -m, build, access, git push origin. Okay. So that one actually ran. So this is actually all the software that's available in EESSI. So that was the one from before, but we have a new one that's running now. So let's take a look at this. So we can see again, have this new commit because I added this build process. It's running in two cases. Let's have a look at the ARM one. And should be very quick because we can see it's actually using a cache now as well. So some of the time-consuming steps are cached in our action, and so they run pretty quickly. I think this takes around 30 seconds. Let's see for each of these. Yeah, here we go. We're already on it. We can, if we click on here, we can see it's built with EESSI right now. And let's stay here for the moment. You can see the commands that it's going to run. These are all the ones that we've seen before. We've seen it's, oh, we forgot something. No, it didn't matter. We didn't load EESSI. Yeah, it didn't matter. That's okay. That's correct. Sorry. And then we can see it's the same kind of text that we saw locally as well. It's again loading that GCC 13 compiler. Things worked. It said it couldn't find the executable. Let me see. I forgot the step. Okay. So I missed one thing. I ran CMake. I forgot to run make, right? So I forgot to actually make the executable, right? So it's complained about something. This is not a bad thing, right? So I recognize, oh, missed the build. I missed the step in the build process, right? So let's add the same file again. I'll cat it for you so you can see it. The fix that I made. I want to commit again. So I want to add missing in a make step, right? Git push origin. Okay, so again, it's going to trigger CI, right? So I got notified, right? There's a notification there that something was failing. And we can look at the history and see that if we wanted to. We can look at these commits. So we can see we had successful CI on this commit here. We had failing CI on the last one. That's because I missed the make step. And now we've got on the current commit, now we've got that CI is running right now. So let's have a look and see what the status is. So it's still running getting EESSI available on the platform. That shouldn't take too long. 30 seconds to a minute is usually what it takes. Let's have a look at the other. Yeah, this one is already running, right? So here we see CMake is running. And then it's built our software. So, and then it's running our test. And so we get a tick here and we see a tick here, right? So now we have CI on our project. All right. So we built something locally. We managed to build it remotely. Now, I thought I would do this a lot quicker than I have, right? So I recognize the time here is it's already 20 past 2. So while I wanted to go through step by step about how I created the recipe for the EESSI config and to use it EESSI extend, I think I won't have time for that. So I'm going to just explain that recipe to you instead. Right. So what I would do in this case, so what I want to do is I want to use something called EESSI extend module load. Well, first I want to clean the environment that I have, right? So let's get rid of this file for now. So I want to do module avail. What do I have right now? So I have not module avail, but module list, right? To see my current environments, right? So these are all the things I have right now. I want to purge those for now. So I want to get rid of all the modules that I have loaded. I want to load EESSI. So if I do module list right now, you'll see there's nothing there. Module avail. You see there's an EESSI module, right? So all the other stuff is not available until I load that module. And the reason we do it like that is because in the future, when there are more EESSI versions, you want to be able to dynamically select which EESSI version that you actually want, right? So we load EESSI, that'll be the latest version. And then we also want to load a module called EESSI extend. So that was already explained in sessions previously. But basically what this module does is set a certain set of environment variables related to EESSI build so that you can extend the environment, right? And so it gives you some information about what it's doing for that. So it's saying, oh, I'm going to build things in this directory. And you can influence the options here a little bit, but this is going to be a user install. So it's just for me and not for other people, just for me. To be able to do this, I need write permissions in this location and I have them, right? So that's local. And then we want to configure sources. If you want to configure sources, that's like more details on the EESSI build site. You don't need that for now. Right, so what we would do next is we would make a directory, EESSI build. Or it doesn't have to be, could be anywhere, right? But for me, I'm going to make a directory EESSI build, and then I'm going to touch file, EESSI build, CI, CD, demo, oops, yeah, the demo.eb, right? I'm not even going to give it a version actually for the time being, right? So what I want to do is I want to create an EESSI build file for this. Now, this project uses CMake, right? So when you're learning to navigate your way around EESSI build a bit, you'll understand, you'll start to learn that the command line is quite powerful, right? So the help is extensive, right? So there's a lot of stuff in there. So and then when you understand a bit about the architecture of EESSI build, you'll understand that there are things like the EESSI block, which is like basically the core of the recipe to build the software, and then the EESSI config, which is the specific recipe for this current version of the software that I want to build, right? So first I need to know what EESSI block do I need for my software, right? So I know that mine is is CMake, but I want to find information about easy blocks. Now, I'm not going to show you EB minus minus help because it's a lot of content, right? So you could pipe it through less to read it in your own time. But in this case, I just want to grep out something particular, right? So I want to look at, let's do it, character, not care about case, right? So easy blocks. So you can see there's an option in here that I can give to EasyBuild to tell it to list the easy blocks. Let's do that. EB minus minus list easy blocks, right? Take a second to this. And then it lists all the easy blocks, including all their inheritance as well, right? So where do they come from and what do they inherit from? The one that's interesting for us is way, there's lots of them, right? But it's way back up here, right? So it's CMake make, so that's like, you saw our build process. Our build process is basically run the CMake command, run the make command, do other stuff next, right? So what we are interested in is the CMake make easy block. And then we want particular options related to that, right? So let's see what the options are available to the CMake make easy block, right? So for that, there's another argument to shortcut things a little bit. I'm going to tell you what the rather I could have looked through it and I looked through the help command to figure out what this would be, but there's an option called available easy config params, and then I want to tell it which easy block to inspect a little bit. So you can do that with this command, CMake make. Oops, there we go. And then in this specific case, that would give me lots of options, right? That I could use in my easy config. But I'm not interested in those because what I really want to do is be able to run tests, right? So I care about tests, right? So I'm going to grep -i test out of this and see what options are there related to my test, because that's what I really would use. So I can see here there's this test command here, there's tests up, there's run test. So for this one, it says make target to test build or true to use C-test. Oh, true to use C-test. I actually want to use C-test, right? So that sounds interesting to me. Now, I don't want to build the entire recipe from scratch. I want to start from a good place, right? So what I typically do in this case is that I actually go to the easy config repository of EasyBuild, and I'd look for an example that does what I want, right? So I want CMake make as an easy block, and then I also want something that uses this run test command as well. And then I just search for it, right? And I'll find something that's pretty recent that uses that stuff, right? So like this one, that's very recent, 2023A. I think that's even the tool chain that I was using myself, right? So that sounds good. Let's go for this one as a base. Let's have a look. What is it? It's a bit small here, but let me blow that up for you a little bit. What's it got? Okay, it got the name version. That's all standard stuff. It's got a tool chain, so it tells me what it's going to build with. There's some options on this one. Maybe I don't care about those. Oh, I have to give information about how to get the source files. Maybe I need some configuration options. I don't think I need any because I didn't give any when I was on the command line. It doesn't need something like this. It doesn't need this extra stuff. So there's some things, build dependencies and build dependencies. Dependencies, let's see. In my case, I needed HDF5, right? I know that I need that at runtime, right? And in terms of a build dependency, I also need CMake, actually. That's what I need to build the software. So basically, we can go through these things and look out. The trickiest thing when you're talking about building in CI is where do you get the sources? So which sources am I going to use exactly? And checksums, that's going to be difficult in CI because it's constantly changing all the time. So there's actually an example for this in the EC docs as well. So it's about easy config files with software commit. And it explains a little bit about how to do these things. And so luckily enough for us, the example that's given is pretty close to what we actually require ourselves, right? So it uses CMake. This is a different package, right? But there's a lot of stuff we can reuse here. And this devel, it explains this thing called software commit. So basically you can give an option to EasyBuild on the command line, and then you can use that command line option to inject a certain commit into the repository, and it will go and fetch that source then from, in this case, from GitHub, based on that commit, right? Because the sources, because of the syntax of GitHub, we know how it is, right? That you can actually download the commit of a certain, you can download the source code for a particular commit using a certain syntax. So we take advantage of that here. Now, given the time, like we're already an hour in, and I won't be able to go. I wanted to develop that recipe from scratch. I'm not going to have time to do that. So I'm going to shortcut things a little bit and take the finished product, and then I'll walk you through the finished product. So this is what the finished product is going to look like. So let me put that into my editor. So let's open it up first. So do I have a file inside? Yeah, I do. Right. Okay. So this is the final content that I would have ended up with, right? So I would have taken that CMake make easy block. I given it a certain name, and I want the version, which is devel. I want the version suffix because every time I install, that installation is going to get a name. With EasyBuild, it gets a name. I want that name to be unique to the software commits for it to be obvious to me where it came from. It doesn't have a home page, although I could have put it maybe the GitHub repository here. The description I got from the project itself. I'm telling it which tool chain to use here. No other options. The GitHub account, it says easy here, but I actually don't want that. I wanted to use my GitHub account. So it's going to use my copy of this repository. And then it gives the structure then of what the sources look like. And then it tells it which exact sources to use that's based on the software commit. And then I have my two dependencies, right? My CMake, my HCF5. And this one, I wanted to explain it a little bit. So some of the things that happen inside EasyBuild maybe sometimes seem like magic, right? But a lot of projects that use CMake make, they use ctest in their testing step, all right? And this is just a shortcut to tell EasyBuild that, right? To say, yeah, use run test equals a true means in this case that you're going to use ctest to run your software. There's also sanity checks in the end. So when I do the make install step, I end up with a bin directory in the place that I wanted to install to. And inside there's actually going to be two files, but I'm only checking for one. I'm going to make sure that this final executable that exists, right? And then I give a class to the module at the end. So we can save that. We can build that locally. So let's have a look at that. Let me just cat that for people as well. So cat easy build CI/CD demo, right? And do a module list, right? We see we have the EC extend module loaded. So now we can do EB easy build and the CI/CD demo, and it will complain eventually. It will complain, right? It complained because it's a bit hard to tell why it complained, unfortunately, in this case, but it complained because I didn't tell it the commit to use, right? So you can see the file that it's trying to look for. It's just blank, right? Because I never told it what commit to use. So let me add that to the command line, minus software commit, and then I need a commit. And that commit has to exist in GitHub, right? So let's go back here and look at what's in GitHub. Where am I? Let's go back and look here what's in GitHub. Where's my GitHub repository? And this one, that all succeeded on the two architectures. Very good. Let's look at here's our history. Things are running a bit slow for me, but there's the commit, the last commit in the repository. So let me take that. So the thing about this recipe is it's not using the local resources, it's using the ones that are remotely available, right, on GitHub. So let's have a look at this. So I got that commit, I paste it here. And then you can see it's running through the various EasyBuild steps, right? So we use some hooks and things. You can see, oh, it managed to find these resources. It's giving me the SHA sum for that. I didn't include it in the file because that's going to change every time, obviously, because different commits are going to have different SHA sums. We can see it's unpacking. It's loading the modules that it needs to run. It's doing the configure step for CMake. It's seeing that seems to be working. It's running that right now. Should be very quick. I think my resources on my machine are a bit heavy at the moment because of all the stuff that's happening, but that should be very fast. There we go. Right. So it's configured. It took 30 seconds to configure. It's doing the build step. In this case, it has I have 8 CPUs on the machine, so it's allowing it to be parallel up to 8 CPUs. It's running, it's running the test step.
While you're waiting, Alan, there's a good question that popped up in Slack on
Yeah,
LD run path. So the easy documentation mentions that you can set LD run path based on library path if you're doing manual builds on top of easy. But why is that not necessary when you're doing builds with easy build on top of easy?
because and this is something that we will fix soon, right? So in EasyBuild is using wrappers around your compilers, and it's taking this library path and splitting it up into components, and then injecting those components into the executable. So it's saying, and that's called like, and we use what's called RPath to do that. So basically, that's injecting locations to look for libraries into the executable or library itself, right? And so the linker, regardless of what that linker is, will look in those specific locations for the libraries first, right? Now, the exact behavior depends a little bit on how the thing is how the library or executable is compiled. But in our case, we're very careful, right? So we make sure that the only thing that we set is the RPath. And that means that all of the libraries that were available, or all of the locations that were in the library path, if they are used, they're available in the executable or library as well, right? And so the linker will look there. And EasyBuild, we changed EasyBuild to do exactly that, right? To do that kind of injection and make sure that such problems with not finding libraries will not exist with something that's incorporated into Easy. Of course, when you're building your own software on top, that you're not necessarily using those wrappers and that we've created. And that's what's changing between today and tomorrow, right? So with some changes that we've introduced into the latest version of EasyBuild, we'll be able to export those wrappers so that you can use them. And there'll be a new module called build-env that you would load on top of like EasyExtend, which will be the compiler wrappers, which deconstruct the library path and inject those into any library, anytime you do linking, like so when you're compiling your code. And so you won't see those problems anymore. And so here we finished. This recipe that I created, of course, unfortunately, it's a worked example, right? So it works straight out of the box, right? But what we would like to do very quickly, because I'm very aware of the time, is that we'd like to make a workflow that executes on GitHub in our GitHub actions to do exactly the same thing. So let's have a look at that, right? So again, let's touch this file. So we got the workflows, .github workflows, and then let's call this one easybuilds.yaml. And let's open that one up. That's a new one. Again, I'm conscious of time. I would have liked to do this thing line by line with you, but I don't have enough time. So basically, we'll reuse what we did before. So let's have a look at the other one first. So let's take the same context and just change the things we need to change, right? So in this case, instead of module load CMake, we're going to use module load easy extend. That's all we need. And then there's a couple of things I would have liked to do to go through them one by one, but basically what we want to do is 2 lines. Oops, let's go through. Let's go to line when we get there. Easy extend by default, it does debug logging, right? So in its log file, it has tons of information about what it's doing at every single step, right? Now, in a CI environment, we don't have access to those log files, right? So we can't see them there. So one option that we have to see the contents of the log file is to actually, and EasyBuild has an option for this, is to log to std out, right? So it logs directly to the terminal all the things that it's doing. And maybe, especially if something fails, we want to see that information, right? So one thing we can do is we can log directly to std out, but in that case, we don't want to have debug logging. So what this does here, this onset statement, is turns off that debug logging because we just want to have basic logging if we're going to log to the screen. And the other thing that happens here is we want to set the software commit. Again, knowing how to reference the current commit in CI, that's something that you can Google or you can ask ChatGPT and it would have told you what that's needed. But that's basically very similar to the command line we already have. And then I have to tell it what to build, right? The CI/CD demo, right? So let's add that. Let's do this quickly. Add the GitHub. We add this new file, git commit. Let me cat it for people. Sorry, GitHub. Easy build. Let me just check the name. Build with easy extend. Let me change them. And then here, build easy. Easy build. Let's call this. Everything else looks okay. So let me save that. And cat it here for anyone who's looking there. And then git, I have to add it again. I made a little change. The easy build YAML file, and then I may not have added the CI/CD demo, so I'll add that too. Git commit -m build with easy extend. Git push origin main. Let's have a look. So we go back to our repository, and we're here. Things are moving a bit slowly, but now we see we have 4 jobs, okay? We have the original build job, which is just building with easy, and now we have 2 more, which are building with easy build, right? So this other workflow as well. Let's have a look at those, what's happening. It's just loading at the moment. Unfortunately, you don't have time, right? So I just say this will work. So we've got a successful build. The last thing I wanted to show you was the same thing running on GitLab. Come on. Okay, so the last thing I want to show you was the same thing running on GitLab. The syntax on GitLab is different. So it does things a little bit differently, but basically it has a file .gitlab-ci.yaml. And that's the file that you need to edit there. So in this case, GitLab, again, we can look, the place to look first when you're looking at this is in the documentation, right? So look at the documentation for GitLab. So by default, it brings you here, but what you really want to read is the README, which tells you what to do. If you read through that, it gives you instructions. It gives you an example here, and that's basically all you need to be able to go again. So let's look at that. That's the basic example. So we just need these components. There's things that we don't need module lists anymore. We can take the commands. I'm going to inject them directly because of time. But basically, they're exactly the same commands that I ran in. That I ran in GitHub. I'm going to run them here. I load easy extend. I onset that debug environment, and then I do my building and my testing. Right. The difference here is the commit SHA. The way to reference the commit is different in GitLab. Again, you could have used Google or ChatGPT to figure that out. But the rest of it is the same. Now, the thing is, our recipe is getting its information from GitHub right now. So the sources are GitHub. So even if I push this to GitLab, it's getting information from GitLab. So the first thing I want to do is do git add .gitlab. Right, add this first, git commit -m. Add GitLab CI git push origin. So I'm going to first push it to GitHub so that I have the same commit in both places, right? So I could git push to origin and then main, then git push. Yeah, I've already added GitLab, the remote. Let me just show you git remote -v to show you. I have another location, another GitLab repository, a GitLab repository as well. So I'm going to push it there. Git push GitLab, right? So it's the exact copy of that. We push that there. Okay, so we can see. Let me go back here. So we can see in the original one, whoa, it's building with easy extend, but the original one is that already succeeded for x86-64. It was building with thing. We've added the GitLab CI here, and then in my GitHub repository, in my GitLab repository, if I reload this page, you'll see that things are happening too. So in the case of GitLab, it's over here. You can click on this and it will show you the workflows that's running right now, the pipelines as they're called in their parlance. So the first thing that happens is something that configures easy. And the second one is that build. We can go and look inside the build. And this one takes a little bit of time. Maybe we'll come back to it at the end, but it's running right at the moment. So basically we were already running in GitLab CI. So I think that covers everything from my demo. I understand that was really quick, but hopefully you got something out of it. Let me get rid of this. What's going on here? Slideshow. Whoa. No. Sorry about this. My machine is running very slow. Okay. So I'm near the end, and I'll just take a couple more minutes and then we'll open the time for the questions. The cheat sheet is there. So the things, like especially the finished products that I showed, they're available on this HackMD pad as well. So like I understand that I ran through them a bit. If I was doing this again, I'd probably take significantly more time to go through them step by step. But basically you saw that we could build our software with Easy, that we could build our software with Easy in CI on GitHub. And then we extended ourselves to build it with Easy Build, and then run that also in CI. So we have the two builds going on at the same time. And then we showed how easy it is to transfer that also to GitLab instance, right? So the same thing, but in the GitLab space that also works, right? So the first step is really just getting our software to build with Easy in general. And then whether we use GitHub or whether we use GitLab is not really that relevant anymore because the environment that we're using takes care of it, right? So Easy is taking care of that. So in terms of the other part, right, CI and CD, continuous delivery, what is that? So continuous delivery, so there's a difference between continuous delivery and continuous deployment, right? So sometimes they're used, the D is different, right? So in continuous deployment, what that typically means is that when you run CI, at the end of it, you actually fully deploy the application, right? So you actually deploy it all the way. So the deployment actually happens directly afterwards, and that's immediately deployed. In continuous delivery, it doesn't work like that. So in continuous delivery, you have the CI part, which makes a piece of code that could be included in sometimes what's called, like I say, a release candidate or something like that. But then there's a manual process before you decide to make a release, right? So that there's some developer who decides when's the right time to make a release. And that's more typical of what would happen in the HPC space, I would say at least, right? So this idea of having release candidates and then having production releases, right? So we have release candidates where we have something that we think is a good candidate for a production release. That might go through extensive testing, including things like scalability, performance, and things like that as well, before we say that that's a production release, right? We make a production release of that. So we still have this case where developers commit code and that triggers CI. And then if those tests pass, then that code could be included in a release candidate. It's eligible for that. And then what happens is then that the release candidate is deployed somehow to like a staging environment so we can actually test it out further. So regression tests or the scalability tests, performance tests, things that we need to do. That might be manual. It might be automated. Ideally, of course, it would be that this is primarily automated. And then the approval takes place as well, right? So somebody approved this and say this is good to go, and then the release candidate is promoted to production and then shipped out in some controlled way. So what can Easy do for this continuous delivery? Well, we already provide a way for you to deploy that application, right? So we have this production repository, software.easy.io. What we need from you to be able to do that is we need that recipe. We need this. That's why I wanted to go through creating this Easy Build recipe. We need a recipe that allows us to build that software using Easy Build, because Easy Build is what we use to deploy into software.easy.io. So if you have a recipe for your production release, or maybe it already exists inside Easy Build, that's all we need to be able to deploy that software in software.easy.io. There may be a little bit more to it because we support so much hardware, right? So we actually go and try and test this build, run this build and test this build on lots of different hardware, right? Lots of different CPUs and everything. And sometimes we find problems, right? And then we can come back to the developer and say, there are issues here, and we can show them where these issues are. right? And then we can try and potentially solve them together. And we've done that a few times already in some even large applications. What we're preparing right now is something called dev.ec.io. The intention there is to use that mostly for release candidates, right? For something that you expect to be able to promote to a production candidate. The idea with dev.ec.io is it's ephemeral. It's not going to exist forever. It's a candidate that you put in place. And then if it works, it might be promoted. If it doesn't work, you replace it with something else, right? But it's not meant to exist for a long period of time. What we want to do is give more control to developers so that rather than have to go through us, they're the ones who decide when I want to deploy something. And if it doesn't work in every architecture, maybe they're okay with that because they want to deploy onto specific architectures because they want to test in a certain environment, right? So we want to give a bit more control to developers for that. And then because it uses similar deployment mechanisms to what we use in software.ec.io, it means that you'll have access to specific architectures, to whatever we support in dev.ec.io, maybe the most interesting ones, probably that means the most challenging ones. So maybe vector instructions on ARM CPUs or RISC-V environments, or potentially things with special hardware, right? So maybe you want to run your tests on AMD GPUs or on some kind of like high-end NVIDIA hardware as well. This is potentially possible, right? If we can find the money to support that or support for sites that help us support that. And so that's something that we can do. And what we're working on in general as well is getting site support for the EC test suite. So the idea behind the EC test suite is that we have tests for applications that include things like performance and scalability checks as well. And we could potentially include applications that are delivered via dev.ec.io in that test suite. And then we centrally collect the information from those test runs. And that could be leveraged by dev.ec.io. And it might help developers, and that would remove the need for them to have direct access to each resource to be able to run, like especially something like scalability or performance tests, that we can collect that information for them on their behalf and then make it available to them. And so that's something else that we could do. And that's basically it. So yeah, sorry, I'm a little bit over, and so I've eaten into the question time a little bit, but I'm here to take questions now, and then all the links related to EasyBuild. Oh, actually, this is from last week's slide. I should have updated it, right? It includes all the links to EasyBuild, but actually should be the easy stuff. Probably that's more linked here. But there is really interesting stuff. So this stuff that happened in the 10th EasyBuild user meeting, there's a lot of content in there related to this as well. I should probably update this slide with the easy specific stuff. But there's more links to the easy stuff. So I think that's it. That's the funding as well. Yeah, so that's it. So I'm open for questions now.
Right, excellent. Thank you, Alan. There are a couple of questions popping up in Slack, but I'm hoping those people are willing to ask the question themselves in Zoom. So I think Pablo is up for that. Pablo, let me allow you to unmute yourself. Yeah, that should work now.
Hello, can you hear me?
Yes.
Yep.
Yeah, thank you, Alan, for the presentation. It has been really interesting. I wanted to ask, would you mind giving some more details on how you make EESSI or CVMFS available in the machine where GitLab Runner is running, especially for self-hosted GitLab instances? I mean, is this something that is taken care by the GitLab component, or you pre-configure this on the machine and then you put the component on top?
Yeah, so I mean, this is a technical detail, right? But I'm happy to tell you how we do it. So the way GitLab components or GitLab CI works in general is quite different to how GitHub Actions works. And so they have these artifacts that they ship around between different stages of a build. And I manipulate that to create a script that I point bash_env to. So bash_env is a variable that I also use in the GitHub component or GitHub action to configure things, right? So it contains lots of the setup to make things work. So that's what happens in GitHub Actions. You have this kind of root, right? So you have this ability to install things, and I do all that installation. Well, in GitHub Actions, it's a little bit different, but I still use bash_env inside GitHub Actions to actually configure easy. In GitLab, inside bash_env, I hide a lot of stuff. So basically, if you're on a self-hosted thing, and if your image already supports CVMFS, it will just start working, right? If it doesn't support CVMFS, it's going to try and install the packages that it needs. And if you don't have the rights to do that, well, things are not going to work in general, right? So it's just going to error out quite early on. But if you do have the rights, so let's say like in Git, if you're using self-hosted and you're still using like the same images that you, so this is the same setup that you have upstream in GitLab, and then all it's going to do is go away and install the packages that are necessary to get that working, right? And it has some checks in there to make sure that things are working. And that's it. Basically, we just hide stuff inside bash env. So inside that bash env is a kind of a complex little script that runs to configure things on a node. So maybe we can actually look at that because it's running right now. This one. So we can see. It said, oh, it failed for some reason. I know the problem is. I could fix this right now. So the version I used of the action, I fixed this last week. The version I used of the action should actually be 1012. And so that version is wrong. I'm going to fix that now. Sorry to do this, but git add, git commit, -m, fix component version, git push, push it to origin first. Main. So I want to make sure that it's clear to you that it does actually work. Git push, git lab main. So this time around, it would actually succeed, right? So it didn't in this case, but I can still show you. I'd actually like to show you because the reason it failed is because I added some additional things to the script for a particular scenario. So the weird thing inside GitLab is that you're actually running as root. So you don't need sudo, you're actually running directly as root. EasyBuild doesn't like that, and MPI doesn't like that as well. So I had to make some changes to the script to affect that. And so now if we go back here, it's probably running, yeah. And hopefully go to jobs, pipelines. So this configure is the one I'm interested in. Inside here, you can see the script that's running. So this is the bash env script that does all the configuration. So it only does these things. So basically, it's just checking if a certain directory exists. If it doesn't exist, I try and do stuff, right? So sometimes in some containers, you don't have things like curl available. So it does some stuff related to that. To download a particular file, and that's that file, then that does all the configuration. And then there's other things related to configuring direnv. I didn't get into what direnv is. So hopefully that answers your question, but maybe that's too much information. Sorry.
Yes, it does. Thank you very much.
Yeah.
Okay, there is another question from Diego in Slack. He can't raise it himself, so let me just read it for you. Does dev EasyIO serve as a testing ground for EasyBuild as well, or is this for only assessing builds on top of Easy?
So it could in the future. I mean, it's something that we're thinking about a lot these days, is how to do more testing for EasyBuild and for the EasyBuild recipes in general. So EasyBuild could be a project that is supported by dev.easy.io, and that's certainly something that we're thinking about right now. There are some caveats to that a little bit, because we probably wouldn't ship what we have in dev.easy.io for EasyBuild, because there are many things that we're not allowed to ship, right? So there are like what we can ship in Easy is things that we're allowed to redistribute, right? But the recipes that we have in EasyBuild, they're far more extensive than that. So in some kind of special configuration, yes, something like that, right? But not specifically in this case, because what goes into dev.easy.io, a developer who uses it has to be careful, right? And we will make this clear. You have to respect the licenses of the things that you're putting in there, right? So if we give you the power to distribute things via CERN VMFS, you need to respect that, right? Because there are licenses involved in the software that you're distributing. And so if you distribute something that you're not supposed to, that's not our fault, right? We're going to tell you that you shouldn't be doing that. But we're going to give you the power to do that. So you just have to be careful yourself. I mean, we can try to some extent to to be careful there. But we also need people to understand that too.
Yeah, maybe to add to that, the DevEase.io is mostly for, I would say, software developers that want to build some kind of pre-production version of their software to then play around with on a variety of systems. Maybe on their own laptop, but also on supercomputers where they know Easy is available and they just want to make, let's say, one build that works across all these systems and then play around with it. The use case that we have for testing contributions to Easy Build is quite different. So although technically it would be possible, I wouldn't say that's the kind of use case we're aiming for. Yeah.
What's one thing that, I mean, the kind of infrastructure that we're creating to make this possible, one thing that we might look at is being able to put GitHub or GitLab runners into Slurm queues, right? So being able to deploy runners that report to jobs and can take jobs and managing that via Slurm. So that's something that we're also thinking about as well. And there's a lot in this space that we're thinking about, especially to help EasyBuild, right? To make it easier for EasyBuild to check and include contributions.
Yeah, we're getting some more questions in Slack. We'll raise them, but if those people are willing to raise the question yourself in Zoom, please raise your hand in Zoom, and we can allow you to unmute. So, oh, there goes Adam. So let's let Adam ask his question first. You should be able to unmute. Yes, there you go.
Hi there. Yeah, can you hear me?
Yes.
Yeah, super. Yeah, so it was just a question about ORPath. I think read somewhere or heard it somewhere recently that when building software on Easy, you shouldn't set an ORPath to point to the compatibility layer. I was just wondering if that's true, if I actually picked that up correctly, and if so, why? Sorry, it's a bit unrelated to CI/CD, but
no, but it's very related to this. Oh, the picture is gone. Well, let me put it. It's in these notes. Let me put it up here. The basic answer is you don't need to. So when you build something, so if you remember this image again, right? That you have the executable, which is talking to this dynamic or runtime linker, and then it's deciding which libraries to load. When you build something with the compiler from inside EC, the linker that you're using is the one that we ship because we control where it looks, right? And so the thing is, you don't need to link to the compatibility library because our linker already knows to look there. You could do it, but you'd have to make sure that it comes right at the end. It's the last thing to check, but you don't need to because it's checked by default. It's one of the default locations where it's loaded. And the danger is that the thing that wouldn't work is that if you tried to RPath the system location for libraries, right? So say /user/lib or something like that, because then it will look in that location, and that has tons of files, right? Tons of different libraries, and then you end up mixing two different operating systems, and that's not going to work out well for you, probably. So the basic answer is you don't do it because you don't need to. Not that it would have any specific harm, but you shouldn't need to do that. And if you need to do that, then there's probably a problem somewhere else. And specifically in that case, like it's better not to do it because you want to see that problem. Because in the end, like for example, if you want to use something with a GPU, and our linker knows to look in a very specific location for your GPU drivers, right? And the other linker, the host OS linker doesn't know to look there, right? So that's why you want to be using our linker. And so you want to know when our linker is not being used because that's going to cause you problems, hardware support problems.
Cheers, thanks.
Okay, Loris can ask his question as well. Go ahead, Loris.
Yes, can you hear me?
Yes.
Yep.
Okay, cool. I was wondering if you have any examples of automated CI tests for typical MPI applications. Applications using MPI. And second part of the question, if you even have tests where you can, for a multi-node type of runs.
Yeah, so I mean, okay, let's do the first one. So the example that I gave was running MPI. So the test that it runs is running four. It was running 4 cores, right? And creating a file that writes each rank is writing to a file, right? So it is running MPI already in that
Okay,
environment,
sure. Yeah.
right? So that's that. Now, this is a simple world, right? So I've set it up so that GitHub or GitLab is not going to complain if you oversubscribe the resources, because in this case, in that test suite in particular, it's hard coded to run for 4 ranks, right? And what if you don't have 4 ranks available? So specifically, like with OpenMPI, it's going to check what hardware you have available. It's going to see, yeah, okay, in GitHub Actions you have 4 virtual cores, but only 2 physical cores available to the runners that are free, right? And so in that case, it's going to complain that you're trying to oversubscribe. So I'm cheating a little bit here because I've set it up to allow this oversubscription. So it's not going to complain about that. It's just going to try and run. And so in this case, it works, right? Multi-node, you can't do that there's no easy way to do that or at least not that I'm aware of, right? In GitHub or GitLab, there wouldn't be any easy way to do that. So that one, you'd have to think about more about this reframe stuff that I was talking about, where you do more like different kinds of tests and where you might do scalability and performance tests in reframe, because that does support doing it.
Actually, yeah, I was thinking more of like a self-hosted type of agents. Yeah.
Even in self-hosted, I mean, it would be possible, because if you allowed your runner to access Slurm, you could say, go and, run a Slurm job. But it would be all, at least as far as I know, right? I don't think there's any easy way of doing that. That would be all infrastructure you'd be building yourself.
In the case of EESSI, are you already doing some of these tests? Typical simulation packages. How do you do that?
Yeah, so our test suite includes, right? I actually don't have the full list of things that it includes, right? But it includes LAMPs, includes GrowMax.
Yeah.
It's running these things up to, I'm not even sure how many nodes at the moment it's running up to.
8 or 16, I would need to check.
Yeah.
Okay.
So we run regular checks. That's just in general as like health checks for the applications, but it also shows the principle, right? That you can run these test suites regularly for different sizes. And so you can imagine, again, this is this use case of dev.easy.io where you could have this changing commit hash, right, that you might be running against all the time to run like the latest, like, let's say like a nightly or a weekly or a monthly build for some of these test suites to look at performance differences and changes over time. So right now we gather that information and we actually present it as well. So I think that probably has appeared in one of the other talks about where we gather the performance information.
And you're using Reframe to do that? Or...
And we're using Reframe, yeah.
Okay, thanks.
Okay, I still see Adam's hand raised. I'm not sure if he has another question or that was just from before. I don't see any other questions. Okay, he lowered his hand again, so it was from before. There's no additional questions, so I think we're ready to wrap up then. Yeah. Thanks a lot.
Just to show you one thing, just to show that it did work, right? So the job succeeded in GitLab as well, right? So I didn't want to leave it looking like it was broken.
Yeah.
It wasn't.
Just make sure to use the latest version of that action.
Which is always probably true. Use the latest version.
All right. Then I think we're ready to wrap up. Thanks a lot, Alan. And just as a reminder, there's one more session next week about using EESSI as a base for building a central software stack. Yeah, Alan's going to bring it up again. If you haven't registered yet, you still can. And that will be the last session in this series. The recording for all 3 previous sessions are already available, and the one for today will be available in a couple of hours if everything goes right. So thanks a lot, everyone, for attending, and see you next week.
Thanks a lot. Bye-bye.